So my name's Tom Espach. I'm going to be talking to you about research and development at Jumpsec. So firstly, obviously, who am I? My name's Tom. I'm the engineering lead at Jumpsec. Historically, I've had a heavy focus in detection and response, blue team, capability, that kind of stuff. But over the years, I've kind of gone more into wider research and development in the cybersecurity industry. We like to design, test greenfield projects, so something that doesn't really have an outcome or a goal, just to see where it takes us and see where we can go with it. And I like to summarize this in one line as I like to help produce exciting new ways of delivering cybersecurity assurance. So a lot of you may not actually know that Jumpsec has an R&D team, but we actually do. We have a team of software engineers, data scientists, DevOps specialists, and we kind of all work together with our clients, people like yourselves, to find opportunities in customer engagements. So whether this comes from a conversation that we have today, or it could be through some challenge that one of our red team consultants has been facing with a particular engagement, and we try and help streamline these processes and just make everything easier and smoother, and in all, it basically makes us the heartbeat of enabling good consultancies, to try and make it as easy as possible to help you guys out, really. So to start, I'm going to do a bit of a recap, because most of you actually weren't here at the last briefing. So two of the key areas that we were looking at last time was this project of phishing detection and another one of social threat intel. So I'm going to give a bit of a summary of where we've got to with these two projects. And these are kind of our current and future approach to trends in cybersecurity. So you're going to hear me say the word trend a lot. I apologize in advance. So firstly, phishing detection. We spoke about how we were trying to look specifically at websites that were harvesting credentials. So we're not talking about the phishing email pretext or any of that, specifically because credential theft is still the largest cause of breaches in any organization. So we figured there's a bit of a gap here and a dichotomy in that not many organizations are actually well enough prepared to detect and respond to these kinds of threats beyond stuff like user awareness and training and that kind of stuff. So it's kind of about that. And we've been looking at using a new algorithm using screenshot similarity and also doing some SIEM integration stuff, so allowing blue teams and analysts to quickly respond to in real time particular credential theft events as they're happening. And on the other side of the spectrum, we've been looking at social threat intel. This is something that really excites me because we've kind of realized that threat intelligence as a domain in cybersecurity hasn't really evolved much over the last 5 or so years. And we've been trying to take a different approach to this. So we've been looking at using social media trends, Twitter trend analysis, looking at what's going on Twitter to basically extract out TTPs and relationships between certain threat actors and the way that they're operating. So firstly, I want to talk about this screenshot fingerprinting algorithm that I mentioned. So those of you who were here before, this is actually an area of research that comes from the computer vision domain. And it's really interesting because we've created a new iteration of this algorithm that previously we were looking at the source code of the website. So, we see this HSBC login page. You see a very similar looking HSBC page. It's actually an impersonation page. It's trying to harvest your credentials. Previously, we were looking at the actual source code and trying to compare the differences. And although this worked for some of the sophisticated attempts, we found that a lot of really low effort phishing attempts were still making it through this, because what they would actually do is they would just take a screenshot of this page and they would just replace this username and password field with a field. So the actual website is completely non-interactive. You can't click on any of the links. It looks identical to the HSBC website. So you're probably still going to get fooled. And we found that a lot of these were still actually quite prevalent. So instead, we had a look at this and we researched this algorithm that allows us to generate a unique fingerprint from an image. So we take this screenshot and we generate this image hash, effectively. And the magic of this algorithm is that changes in the image don't cause large changes in the hash, in this fingerprint. So even websites that have, the logo might be slightly different, the text might be slightly different font, they might have gotten rid of these App Store download buttons, but this hash is still going to be very much the same. So we can say with a high level of certainty that this website actually is impersonating or is very visually similar to a HSBC login page. So there's basically, we can scan all the websites that are being visited by your staff members, by looking in web proxy logs and all of this kind of stuff, and we can begin to build out a picture of how similar these websites are to each other in terms of brand impersonation. And then secondly, we've also been looking at how can we cast a wider net in terms of actually what websites we can crawl to find these phishing websites. And in doing so, this is actually quite similar to Google dorking in fact. So a lot of websites will have this same, if they're impersonating the Microsoft sign-in page, they'll have the same title and fav icon. So you can actually use Google dorking and other APIs from other search engines, open source search engines, and things like VirusTotal to find and crawl websites that are impersonating certain other websites. So VirusTotal released a really good piece of research on this about how you can actually set up a regular scan to look for companies or look for people who are potentially impersonating your websites and your brand image. And we're basically doing this to just cast a wider net into the websites that we can crawl. So what do we find about this? Well, through doing this, we're able to crawl around 315 plus new phishing websites on a daily basis. This is great for us because we get loads and loads of data from this. We can pass on all of this data to our blue team, to our analysts. They can start, doing active threat hunting. So we see certain campaign targeting organizations. They can go and look in our clients' organization networks and say, okay, can we validate that any of these campaigns are hitting our clients? And in some cases, we actually have found certain campaigns that were hitting our clients and it was not being flagged by things like Defender or Mimecast or any of this. So we almost get this trend where we can go from finding these campaigns as soon as they're released to actually proactively hunting for them in our client networks, which is really valuable for us because we can continuously improve our algorithm and our data sets, but also provide some value to people like yourselves. And then there's obviously the overarching piece, which is around trends, of course. But because we have so much data that we can aggregate and crawl through all of these websites, phishing domains, phishing websites, harvesting so many credentials, we can actually isolate entire campaigns and particular techniques that adversaries are now using to perform these phishing attacks. A really interesting example that we had recently was we saw a trend where there was in the hundreds to the thousands of AzureWebsites.net subdomains being created, and all of them had the Microsoft 365 login page on them. This was interesting because they were all quite clearly identical. They were using similar dictionary-based words like securelogin.azurewebsites.net and maybe like companyname.azurewebsites.net. And they were just like spamming these out. And we're finding that a lot of this stuff was getting through like companies' mail filters and things. So we did a bit of digging and we got our blue team to actually look into this as well. And one of the reasons we found is that AzureWebsites.net was registered about 15 years ago. So it's obviously a trusted domain, it's well known. It also often you have Microsoft-based SSL TLS certificates on them. So a lot of that level of interrogation that the filters are using kind of fall apart. And also, it's also beneficial to the adversary to use this because a lot of this stuff can be automated on AzureWebsites.net. So they can spin up, modify, remove all of these different domains, IP addresses, all with the same Microsoft login page, almost completely automatically and at massive scale. So that's one of the benefits that obviously the adversaries had to this, and it was harder to detect. There's also a bit of a psychological piece around this that we considered, is that maybe the average person may have heard of Azure. They know that it's associated to Microsoft in some way, and it makes them more likely to trust this login page simply because of this mental association that they have. But this is the kind of findings that we've been able to make with this project, and it's been very beneficial to us, and we're excited to see the way that it can go in the future. So on to the next piece, which is around social threat intel. And in order to tackle this, I kind of need to summarize the differences between what the industry has traditionally called threat intelligence and the way that Jumpsec kind of sees threat intelligence going into the future and where the real value is coming from. So when we talk about traditional threat intel, we often talk about, the classic is going to be your zero-day releases. Tom Elson mentioned earlier today, Print Nightmare, Log4Shell. I'm sure everyone has memories of these, and I'm sorry if I've brought back some horrible memories, but it's probably not the happiest days. But all of this stuff is really, really important, and it's actually imperative, obviously, to stay on top of 0 days as they are released. They're going to help you be better prepared, yes, but this whole 0 day as TI concept, to me, almost falls under patch management. It's not so much real threat intelligence. Sure, you know that this vulnerability could be exploited in the wild, but it's almost too late at that point because this vulnerability could have been discovered by someone who's already been actively using it for many months. So that's obviously 0 day releases. The next one, which is probably what most people think of when they think of threat intelligence, which is your classic domain and IP abuse lists. So threat intel, service providers have been using this for a very, very long time. They basically spin up honeypots all over the globe. They harvest all of this data from all of these honeypots, you know, what exploits are being used, what IP addresses are being used, what domains are being used to deploy phishing payloads or whatever it is. And they collect all of this data, aggregate it, and they sell it en masse to security vendors. And one of the core problems that we found, especially when we were doing our research into this, is that none of these security service providers ever really consider the problem or solve the problem of garbage in, garbage out. So if you have a massive list of 25 million IP addresses that you know are all malicious and they shouldn't be entering your network, how do you know if any of that's actually relevant to you? And is pumping all of this data through some SIEM provider system or platform even going to provide you any value or benefit? So that's a real challenge that we've kind of seen with traditional TI methods. And I guess that kind of leads on to where we see the future of TI going, which for us kind of comes from the point that it's much easier for an attacker to change their IP address or domain name than it is for them to change the technique they use for lateral movement, the technique they use for persistence, the pretext of their phishing payloads, all of this kind of stuff. So really what we're talking about here, and I want to thank Tom Elson for giving a really good rundown of TTP, so I don't have to describe this to you again. But we're really talking about TTPs when we talk about new threat intelligence. And on a broader sense, what kind of relationships, patterns, and trends can we draw from these TTPs that are being used by adversaries? And how can you map this against your organization so that you can actively say, okay, this APT is using these techniques in these ways, and this is our detection controls against each of these techniques that are being used in the wild. So it's really where the value comes from in our sense is from this cyber preparedness. It's looking into the future, what could be happening and what is happening now to other people and how you can prepare yourself against that. So how does this actually look in action? I guess this is a bit of a theoretical, but effectively we've developed a crawling bot, which is just a Twitter bot. And the reason we've chosen Twitter for this use case is because tweets are obviously a fixed length, so people who write tweets are kind of forced to be as concise as possible, and it's much easier for an algorithm to crawl through a bunch of tweets than it is to crawl through massive bodies of reports and documents. Obviously, tweets also contain hashtags, and that's almost like a free version of context tagging, as long as people aren't abusing them, but effectively we can use hashtags to infer what kind of context those tweets live in. And so what we also do is this bot goes around looking at all these tweets constantly. It gives each tweet a value score. So this is basically a score of how good this could be in terms of threat intelligence. And if a tweet scores really highly on this, we actually force our bot to interact with that tweet in a certain way. So we'll say, if it scores 95%, this is really good TI, then retweet it, like it, and comment on it. And the reason we do this is that we found that we can actually take advantage of Twitter's already very advanced machine learning algorithms almost to benefit us. So, we start interacting with tweets that we consider high and good for us. Then Twitter will start feeding us more of these tweets so that we can almost build this symbiotic relationship where we're training Twitter's algorithm and Twitter's algorithm is training us, which is really cool. I really like this idea. So once we have this massive list of tweets that have a sort of value score based on their threat intelligence ranking, we start to extract the data out. So for this, we use a technique called named entity recognition, and we start pulling out things like the techniques, tactics, procedures, the names of the attack groups, names of whatever tools they're using, that kind of stuff. And we just pull this all out into a massive database, like a graph database that we can then hand over to our analysts, and they can start performing the actual analysis and building the insights that really provide value. So this process 1, 2 there is all completely automated, but the analysis is really the piece where the value comes from. And I'm going to show you just now what the output of this actually looks like. So I don't expect you to be able to read any of this. Don't worry, you're not going blind. This is basically a very small, believe it or not, a small subset of the kind of graph that we actually generate from our crawling and extraction. So if you look in these central points here, each of these are attack groups. And each of the sort of peripheral nodes, each of those is a TTP. So you can kind of see in the middle, we've got these attack groups that have a lot of TTPs that are actually shared by other attack groups. And then on the outside, we kind of have like these, where they're not really sharing any techniques with any other groups. But what does this actually look like overall? Well, we draw this insight. There are 10 groups. They're all particularly active right now. They're all using a shared initial access vector, and they're using this to compromise networks in the UK. So we have 4 key pieces of information there that we can start to act on. It's proactive. We know that they're active now because we ran this scan today. We know that they're a threat to us because they're targeting organizations in the UK. And we know they all use this one specific shared initial access vector. So what can we do now? We can have a look at this initial access vector, have a look at our networks, have a look, make sure that we aren't actually going to be affected by this. What can we do if these 10 groups start targeting us tomorrow? Are we in the best standpoint we can be for when that happens? And that's really where the value comes from. So I've spoken a lot about threat intel and phishing, brand impersonation, all of that kind of stuff. But my talk wouldn't be complete without at least talking a little bit about detection and response. And I could stand here and bore you with a bunch of really technical, signature-based and behavioral-based research and development that we're doing. But instead, we've actually taken a bit of a step back from this. And we've been doing some research more into the high-level architectures of detection platforms. So we're not going to be talking about how to detect certain attacks. Instead, we're going to be talking about what sort of architectures are being used by most vendors and what are the benefits and the disadvantages or whatever of these different architectures. And the reasoning is that I almost want to challenge the way that people think about these architectures. So obviously we have to start with centralized detection. Pretty much everyone is using some form of centralized detection, whether that's centralized logging, whether you're using a SIEM platform or anything like this. So I've got 3 sort of pros and 3 cons. I wouldn't call them negatives, but they're more deterrents. Reasons why smaller businesses are not so eager to step into the world of centralized detection. So according to the IBM Data Breach Report of 2021, the average number of days to detect a breach is 287. That's pretty staggering. I mean, 287 days is almost a full year. And I guess the reasoning here is that if you don't have any sort of centralized detection or logging, then you're not going to be able to detect a breach until it's far too late. And that's a true fact. The second one, of course, Gartner claims that organizations without effective centralized detection are at a competitive disadvantage. And obviously this one I would have to agree with. I'd probably spin it slightly differently though and say that organizations with effective detection capability are at a competitive advantage in the case of an incident, because I guess if you don't get breached, who cares where your logs are? But also it kind of raises the question, can you have that competitive advantage without having to have your logs centralized or having a centralized detection platform, which I'm going to dig into next. And then, of course, there's the fact that there are over 50 unique centralized logging solutions already on the market. I'm not saying that the market's saturated, but it's obviously very mature, and there's obviously a reason why almost every vendor out there is using a centralized architecture. There's so many different ways to do this as well, whether you're using one-click cloud solutions, whether you're using on-premise deployments. the architecture remains the same, and it makes you really think, why is everyone doing it this way? Is there a better way? Now onto the deterrents, I guess. The average storage and hosting cost for 500 people organization is roughly 84 grand. If you actually see a quote for less than 100K, then you've probably got a deal. But that's quite a lot of money, really, when it comes down to it, especially when you consider the fact that security budgets, as most people in this room will know, are not the largest budget that the organization generally has. And this is also a massive deterrent for smaller companies, medium enterprises who can't really afford that because they probably don't even turn over that much in a year. Then there's a sort of challenge that I speak from my days as a blue team analyst. The vast majority of these applications and server vendors, they don't agree on common log formats. So as an analyst, you're constantly battling with all these different vendors and all of these different platforms because one might call the computer name this, one might call it host name, one might call it whatever. And it's a real pain when you're actually trying to perform an analysis or triage or anything of this nature. And then add on top of that the fact that many vendors will try and lock you into a particular ecosystem. So they're going to try and charge you extra for pulling your logs out, for moving your logs anywhere else, or sometimes even in an incident they're going to charge you extra just because. So these are all the kind of challenges and things that we're trying to research into solutions for at Jumpsec. Let's see. So I don't know if you can see this very clearly, but this is effectively the architecture that I'm talking about when we talk about centralization. We have the centralized SIEM server, we have all your workstations and servers around the edge, and the blue box is your detection logic. So this is where all your rule engines sit, whether you've got machine learning engines, doesn't really matter. That's where all of the detection happens. And one of the core challenges with this is the fact that you're sending logs, all of your logs, across the network to the centralized server. So every single machine, every single event. If you consider, for example, a 5,000 endpoint enterprise, a single endpoint generally produces around 50 megabytes worth of logs. We're talking about 250 gigabytes worth of logs a day. Multiply that by your retention period. We're talking about, let's say, 90 days. That's 22 terabytes worth of logs, roughly, that you need to be able to store. And then, of course, if you want to do this properly, you're going to want some redundancy or sharding or replication of data. So it's closer to about 50 terabytes. I don't know the last time I looked at a 50 terabyte SSD, but it's not cheap. Or if you look at 50 terabytes worth of cloud storage, it's got to be high throughput. It's going to cost you a dime. And of course, we need to consider the bandwidth considerations. So, this probably wasn't so much of an issue when everyone was in the office. You're just sending logs from this workstation, plugged in over Ethernet, it goes to the centralized server. But nowadays, we're talking about home networks, probably got Wi-Fi that, God knows what they're running, plus net, probably connected to VPN, goes over into the cloud, into an MPLS, might even go back down into on-prem, depending on how you're set up. So there's a lot of data. We're talking about 22 terabytes worth of data in a 90-day period that's going over goodness knows where to get to this server. And there are certain cases where your network may actually suffer from this amount of data going through it. So I'm probably making it sound pretty gloomy, but don't worry, it does get better. So what about cloud abstractions? Obviously, you could be sitting here thinking, I'm all well and good. I've got my Azure license, E5 license, got Azure Sentinel, Defender ATP. Firstly, if you are in that position, I want to say congratulations, that's awesome. The future really is now. But if you're not, then it's not so much a case that cloud abstractions solve all the problems. However, I would say that it is probably one of the best options you have if you're not there yet. Like with Azure Sentinel, for example, you don't really have to think about anything. It's kind of just out of the box. And I mean that quite literally, that most of the time, if you want to implement centralized logging, centralized detection, you literally just check a box in the UI and you just get it. And this is down to the fact that obviously cloud providers have all of the infrastructure, all of the automation capability, all of the engineers to almost do anything they want. So they can solve scalability in a heartbeat. And the power that they have is incredible. But you'll feel like you're always going to be constantly battling this cost and scale line. So even if you do get all of the scalability with Azure, what are you actually paying for that? And also take into account, as I said earlier, I know that Microsoft will charge you extra if you want to pull in logs that aren't of Microsoft format. So if you want to pull your Linux logs in, or if you've got some firewalls that are sat on premise, you want to pull that in, you're going to pay for bandwidth. And all of these extra costs are going to be incurred. But at the end of the day, if you're just looking for a solution to scalability, just do it. Cloud abstractions will solve a lot of these problems, at least from what we've been doing from our research. So what's the other solution? Well, we could talk a little bit about decentralized detection. So this isn't exactly a new concept. This has kind of been around for a very long time. AV vendors have been doing it for decades, since I was a kid. But effectively, if you can see here, this is the centralized detection. And now, instead of having our central detection logic, we push all of the detection logic out to our endpoints and servers. And the power of doing this is that we no longer have to send all of our events through the network to the central server. Instead, every workstation or server is responsible for its own security detection. And this is very beneficial because it means all of that CPU and processing and storage power is now being distributed across the whole network, which makes for a really nice, it cuts a really fine line between this scalability and cost, because that means that central server is just getting detection alerts. And that means that it doesn't actually have to have much storage or CPU or processing or RAM or whatever it is. And it can just kind of sit there and just aggregate detections, respond to alerts, whether that means instant triage or whatever that means. But there's just a lot less requirements, and it scales much more horizontally. You don't have to really think about it as much, as opposed to the case where you need to think about exactly how much storage you're going to need on that server and all of those other complexities. Now, I can already hear people thinking this, but what about my poor endpoints? And I totally get this, because agent fatigue is a real problem in the security industry. Some SOC providers actually push out sometimes 4 or 5 different agents for you to put onto your machines. This gets even worse when you think about the fact that most of these agents have the ability to respond to incidents. And when you get down to a lower level, really all that means is they have the ability to delete processes or kill processes, delete files, modify packets, block ports on the network. They've got a lot of power, and they also run as system-level privileges, so they have a high level of privilege. So I can totally understand this fear. But if you take a step back and you actually have a look in your task manager, you'll see that there's actually a lot of background processes that you probably don't even know anything about. I know I don't. And some of these, even if you do try and kill them, like Cortana I've tried killing, and she just keeps coming back. You don't know what's happening. So I really feel like if you are considering, we don't want to install an agent on our workstations for the sake of security, just have a look at all of these and consider what value these are providing to your organization. And before you turn your back to a particular security agent, at least think that that agent is going to be able to allow you to effectively respond much faster in an incident. And that incident may end up costing you a lot more than just a few CPU cycles on your machines. But okay, we don't need to solve that problem, because we've also been doing a lot of research into agentless monitoring. So, what if we've gone through some of these benefits of having an agent? So, you can do all of this client-side filtering. You don't have to send all of your data across to the central server. You can have immediate response on each endpoint. But also one thing that's often forgotten about is the offline functionality. So a detection agent can actually still function offline when it's not connected to the central server, which is a real benefit, really. But obviously you need to consider that without an agent, you basically don't have to deploy anything. Stuff just, for example, you can roll out Windows Event Collection service just using a GPO. It's almost immediate, and there's not really a learning curve. This is very beneficial in cases where you have maybe a third party who manages part of your infrastructure, and they don't want you installing this weird, scary security agent on their infrastructure. So now instead of that, you can just say, okay, generate me an API key, and I'll just get that data myself, or deploy this GPO. They're probably more likely to understand a group policy object than they're likely to understand some scary executable that no one has any source code for. And of course, there's just more and more APIs and SDKs becoming available for this. So pulling logs remotely is becoming even easier as time progresses. And we even see cases where it's possible to deploy proxy agents, where maybe you're not allowed to install agents here, but you can install one here. So we just install an agent there to pull logs from that location. And this makes it really dynamic in ways that you can actually perform centralized detection. So key takeaways really today. Obviously, brand impersonation and phishing attacks are only getting more sophisticated. So we really just need to find better ways of defending and defeating these adversaries. And that's one of the key things that we're really working at Jumpsec today. We really believe that threat intelligence should be insight-driven and not just data-driven. So we want to solve this problem of garbage in, garbage out, and not all data really holds the same value, and that's really what you need to take home today. And finally, centralized detection obviously isn't going anywhere. There's still 50+ vendors who are doing this, but it's also not the silver bullet, and there are plenty of other approaches that have their own merits and benefits too. And at Jumpsec, we don't really believe in tying ourselves to a single architecture or a single technology, but it's more about applying things on a case-by-case basis, whatever suits you best and whatever solves the problem for you. So that's it from me. Thank you, everyone.